Computer programming is the process of performing particular computations, or more generally, accomplishing specific computing results, usually by designing and building executable computer programs. Programming involves tasks such as analysis, generating algorithms, profiling algorithms' accuracy and resource consumption, and the implementation of algorithms, usually in a particular programming language, commonly referred to as coding. The source code of a program is written in one or more languages that are intelligible to programmers, rather than machine code, which is directly executed by the central processing unit. The purpose of programming is to find a sequence of instructions that will automate the performance of a task, which can be as complex as an operating system, on a computer, often for solving a given problem. Proficient programming thus usually requires expertise in several different subjects, including knowledge of the application domain, specialized algorithms, and formal logic. Tasks accompanying and related to programming include testing, debugging, source code maintenance, implementation of build systems, and management of derived artifacts, such as the machine code of computer programs. However, while these might be considered part of the programming process, often the term software development is more likely used for this larger overall process, whereas the terms programming, implementation, and coding tend to be focused on the actual writing of code. Relatedly, software engineering combines engineering techniques and principles with software development. Also, those involved with software development may at times engage in reverse engineering, which is the practice of seeking to understand an existing program so as to re-implement its function in some way. History. Ada Lovelace, whose notes added to the end of Luigi Menabrea's paper included the first algorithm designed for processing by an analytical engine. She is often recognized as history's first computer programmer. See also, Computer Program Section History, Programmer Section History, and History of Programming Languages. Programmable devices have existed for centuries. As early as the 9th century, a programmable music sequencer was invented by the Persian Banu Musa brothers, who described an automated mechanical flute player in the Book of Ingenious Devices. In 1206, the Arab engineer al-Jazari invented a programmable drum machine where a musical mechanical automaton could be made to play different rhythms and drum patterns, via pegs and cams. In 1801, the Jacquard loom could produce entirely different weaves by changing the program, a series of pasteboard cards with holes punched in them. Code-breaking algorithms have also existed for centuries. In the 9th century, the Arab mathematician al-Kindi described a cryptographic algorithm for deciphering encrypted code, in a manuscript on deciphering cryptographic messages. He gave the first description of cryptanalysis by frequency analysis, the earliest code-breaking algorithm. The first computer program is generally dated to 1843, when mathematician Ada Lovelace published an algorithm to calculate a sequence of Bernoulli numbers, intended to be carried out by Charles Babbage's analytical engine. However, Charles Babbage had already written his first program for the analytical engine in 1837. Data and instructions were once stored on external punched cards, which were kept in order and arranged in program decks. In the 1880s, Herman Hollerith invented the concept of storing data in machine-readable form. Later a control panel, plugboard, added to his 1906 Type 1 tabulator allowed it to be programmed for different jobs, and by the late 1940s, unit record equipment such as the IBM 602 and IBM 604 were programmed by control panels in a similar way, as were the first electronic computers. However, with the concept of the stored program computer introduced in 1949, both programs and data were stored and manipulated in the same way in computer memory. Machine language. Machine code was the language of early programs, written in the instruction set of the particular machine, often in binary notation. Assembly languages were soon developed that let the programmer specify instruction in a text format, e.g., add x, total, with abbreviations for each operation code and meaningful names for specifying addresses. However, because an assembly language is little more than a different notation for a machine language, two machines with different instruction sets also have different assembly languages. Wired control panel for an IBM 402 accounting machine. Wires connect pulse streams from the card reader to counters and other internal logic and ultimately to the printer. Compiler languages. See also, compiler. High-level languages made the process of developing a program simpler and more understandable, and less bound to the underlying hardware. The first compiler-related tool, the A0 system, was developed in 1952 by Grace Hopper, who also coined the term compiler. Fortran, the first widely used high-level language to have a functional implementation, came out in 1957, and many other languages were soon developed. In particular, COBOL aimed at commercial data processing, and Lisp for computer research. These compiled languages allow the programmer to write programs in terms that are syntactically richer, and more capable of abstracting the code, making it easy to target varying machine instruction sets via compilation declarations and heuristics. Compilers harness the power of computers to make programming easier by allowing programmers to specify calculations by entering a formula using infix notation.